Hello, my name is Pedro Alpias dos Santos, aka Proviner, and this is an introduction to Dash, where I want to highlight some of the design decisions behind the package. Dash is a third-party package for side effects Houdini, like QLeap or ALeap. And so basically this usually means a collection of granular, reusable nodes that play well with the native toolset and extend it. And so my package, like the other ones, is trying to identify some caveats in the current toolset and propose some shortcuts to deal with them. This is a creative development project for me, so it allows me to propose, push forward improvements, workflows, standards in a way that is productive, meaning instead of just complaining that some things are missing, I can make these proof of concept, working proof of concepts and show them in practice. This means that also I'm going to have to pull in all the tricks in the book to try to make some of these things work, some of these features work on the surface the way I want. This can mean that, some stuff might be a little bit hacky, but overall should be good enough to represent the ideas behind them. This project also means that I have now a platform and a structure that allows me to continuously publish and support some of these nodes. I've used Orbolt before a lot over the years, and most of the stuff that I put in there was just a singleton item, something that I thought it was useful for me and I thought maybe would be useful for others. And while Orbolt is very useful, it's the approval process is kind of a hindrance when it comes to publish things on a specific time and make things public on a specific time frame. So hopefully I'll have a better time with GitHub on that regard. But some of the nodes in the first release come from Orbolt. So the bend, the vector and matrix display, the range wipe, the connected elements, etc. So while I'll also provide SOPs, definitely my initial focus will be on VOPs. And so here are some reasons of why is that. Nodes are artist technical gateway, or at least for me, definitely that was the case, where I had no programming background, and this visual programming that nodes provide was my first contact with trying to establish a list of instructions that in a creative way. And so that was always very satisfying, and in a way I kind of wish VOPs were a bit more like a first-class citizen and not just an introduction to Vex or a Vex builder. The SOP level is very saturated, and so another reason for me to maybe focus more on VOPs, where I have, there's things that I have strong opinions and I would like to push forward some ideas. So it might be more worthwhile for me in the community that maybe I focus on this context more. VOPs have some advantages over Vex and also have some disadvantages. In a way, they allow me to create like functions that have a rich list of inputs and outputs, and basically I have a nice UI that allows me to immediately have control over the function. This, of course, in Vex, you will have to create those parameters and then use them in the function itself. Here is immediately I drop the node and immediately have those parameters, and also I don't need to define every input and every output. Like I can just, if I want to animate the angle, I just connect the time to the angle and that's it. The time will be animated. Same for the outputs. I don't need to, if I want to use them, I use them. I don't need to define them. So here's something that highlights another difference between Vex and VOPs. So the VOP HDAs have fixed amount of ports, so the data types might change, but the amount of inputs and outputs is fixed. While in Vex, that can change. Like there can be signatures of the function that can have less arguments. So usually what happens on the Vex side is that there are some functions that have longer arguments or more arguments, and some signatures that will have less arguments. That cannot that cannot be done in VOPs, but still, for an operation like this or the noises, it can be very cumbersome to write everything, right? So there's some advantages in there. The other thing that kind of pushed me to definitely, go the VOP way, I even tested this before starting the project, is like, okay, can I use includes and whatever header file or VFL file that I include in my wrangle, can I have auto completion of the functions that are in those files? And the answer is no. And so that's a little bit cumbersome because, okay, I have a nice file with a lot of cool functions, but I cannot have them auto completed in the wrangle code section. So I decided because of that to, okay, maybe it's really, my focus here is really surface level comfort. And so for that, it does make a lot of sense to create a Vex library for that. It makes more sense to create some VOPs. The other reason is to use VOPs is I'm definitely prioritizing surface level ideation. Like I want to have the ability to try new things to be faster, or the price for it to be lower, and have the ability to quickly access information. And so having these rich outputs and inputs allows me to quickly get things and try things without having to pay the full price. This means that also, I'm going to prioritize that over sheer code performance or code optimization. And so, if it's up to the user, if they think whatever I'm providing is too slow, to do their own version. So do I use VOPs? Well, I used it a lot in the beginning when I transitioned to Houdini. Like, for example, this is before KineFX. I was doing a lot of geometry-based rigging experimentations, and this whole thing was done with this VOP network, where there's a lot of for looping in here of matrices. And yeah, so initially, even the HDAs that I put on Orbit internally were using VOPs, the curve deformer, all of those. But eventually I had to move to Vex because there were too many missing functions or nodes in the VOP context, and people just kept telling me, you can just use a snippet VOP. And I'm like, okay, but I came to Houdini to live the life of everything with nodes, and now I'm being told I'm forced to kind of go to code to do something that I think it could be just, I could just use some nodes. I was not very happy at the time, but eventually, of course, it paid off to move to Vex, and now, of course, I can do more interesting VOP HDAs because of that experience. So currently, most of the VOPs that I use are just my own and almost like standalone SOP operations. So for example, if I want to have some nice neighbors function, well, I'll just can use my connected elements VOP, right? And I might just use it to cook those neighbors, not to make any complex logic. Those things I'll probably still be using Vex for that. But definitely this project and this effort that I'm putting forward for the VOPs is to try to change that a little bit. And there are some aspects that I think it made my experience with the visual programming more enjoyable in soft image eyes. And I'm trying to rekindle some of those items, and I'll show them in later slides. So right now, these are the contents of the package. There are some SOPs, there's some VOPs. All of them are black box because I'm not really sure about what's going on with this scraping of repositories for AI training. But all the HDAs have help. Some of them have examples. Some of the SOP HDAs are didactic, meaning they're not supposed to be used in any setup, but they are a demonstration of some principles by themselves, and they can be used in an educational setting. The reason I made them was that I noticed that probably was more useful for some students to actually play with the concepts and instead of me just showing something on the screen. And so that's kind of the purpose. They can be used as a demonstration, but also for the students themselves to play with the concept they're trying to grasp. There are some scripts in the toolbar. There's a desktop. So this is how I'd like to work with Houdini. I thought, okay, I might just include in there, and there will be some of expressions as well. So next I will be talking about some of the design decisions that went into the package. So one of the first things I had to decide is what is the target granularity or reusability for the nodes and dash. And so here I have a spectrum. On the left I have atomic, on the right I have monolithic. And for the atomic I have the example of the neighbors VOP. It does a single thing, that is to return an array of points that are connected to the input point through edges. So it just does that and nothing else. On the other side, we have connected elements that I published on Orbit that not only had a bunch of options to the type of connected conversion that would happen, but also it would return attribute values present on the returning elements. So not just the elements, but also values on those elements. And here is the dash connected elements that it just does one thing as well. It just returns the elements. It doesn't return the values. Now, this operation is way more complex than this one, but it's also more specialized than this one. So this one, it doesn't provide the attribute values, but it does more of the core concept. Like it supports edges that this one doesn't. It has more regions options that this one doesn't. So it is less, but it's also more. So in the sense that whenever I identify that maybe there's an operation that is kind of two operations in one, and if it makes sense, if both of them are reusable, I should just split them into two operations and then connect them. And so, for example, here, this is the orbold connected elements, and this is the dash connected elements, here delegating its elements to the build attribute array, and this will source the values that I had previously here included in this single HDA. And this build attribute array can be used with other lists, other arrays of elements, not just for the connected elements, right? So this is an example of this, the kind of mindset that will go through the project. This build attribute array is not present in the package yet. It's going to be part of the next release. And so I have here an example with where my range sweep VOP was basically shattered into 4 VOPs for the dash project. So the wipe range does the core operation with the bias and the span. Let me zoom this. The ramp takes care of the ramp input in here. The phase is done by the transform 1D. The extrapolation control is done by the limit range extensions. And so, yeah, it's an example of how a single operation was kind of shattered into 4 nodes, and these are all very reusable in their own, on their own. Not so here. It's connected elements again, split into connected elements and build array, build attribute array. Next, we have support for multidimensional floats. And so I will do my best to, whenever like I have math VOPs that work well with a single float, that I can do the same operation on vectors and matrices. Now, this, of course, will break some concepts of linear algebra. But the thing is, sometimes in production, you have to package data into known data types. So maybe I'm dealing with a matrix, but that matrix is not supposed to be a transform matrix. Maybe it's just a way that I packaged a bunch of vectors or a bunch of floats for some specific purpose. And I still want the ability to add them, to interpolate them, etc., as if they were a single float, or like element-wise, do that element-wise for the matrix. So I'll try to support that, but indeed that means I'm going to end up with a lot of signatures to do all that, and a lot of code implementation. So it's definitely cumbersome, but in a way I think it has its value. The also other important thing is to support array signatures, so that one doesn't need to constantly for loop for basic things. I remember in soft image eyes, I could very easily, for example, do an array plus another array, and that would just add the elements of the two arrays element wise, and I didn't have to do any for looping. So here's an example of that with this wipe range. Here is with a float, here's with a vector, and here is with a matrix. And for the matrix, it's not only going to have a signature that has the element-wise control, but also component-wise control. So this vector 4, the first component of this vector 4, is going to take care of the first row of the matrix. And then, of course, for the arrays, here's an array of floats. And so here I just connect that to the operation, while the usual way to do this is you have to get the length of the array, get the for loop blocks, get the element, do the operation you actually want to do, and then set the element back in the array. But this is quite cumbersome, and definitely the idea of having all these signatures is that to shortcut and avoid having to do always some for looping. Some operations I'll probably won't support this. So for example, here I have connected elements that has a single input, but an array output. And so if I would have an input array to support this, I would have to have a multi-dimensional single array. And so that's probably not something I'm gonna stay out of that, but maybe in the future I'll support that. Another thing that is supposed to speed up some of the setup time is having some auto resizing of multiple input arrays. So in Softimage, I remember that if I had multiple arrays coming into a node in ICE, they would all be resized to the smallest array. And sometimes that was useful, but sometimes had some issues because I would have to constantly keep resizing the input arrays so that they wouldn't compromise the operation. So here I decided to actually resize to the maximum, to the largest size. So here we have a practical example. I have 5 ports. They are all array. And the first array has 3 elements, and it's the largest array of the bunch. So this one is going to be unchanged because it's the largest array. The second one has only 1 element, so it's going to be resized to 3. And as the fill value is going to be used the last element, so 4, 4, 4. Third array, it's has only 2 elements, so it needs to be resized to 3, and it's going to use as the fill value the last element in the input array. The last 2 arrays have no elements, and so they're going to use a default value. So the default for last is the value of 1, and the default for last extend is the value of 0. So that's what it's used in as a fill value for these resize operation. So hopefully this makes that there's some guarantee of data parity. So the arrays have the same size for the operation to be properly executed, but also you don't need to pay the full price of curating the input arrays so that everything works out, right? Here's a quick example where I have this build uniform array with size 5, and so my operation returns these 5 elements. Now I have here another array, a build constant array with size 10, and if I put this on the last, you see that now the output has a size of 10 as well. So the largest array is going to dictate the size of the output. Now right now, if I change this to minimum, it's going to not work so well because this port here has nothing in it, so it's an empty array. But if the output is going to be empty, but if I connect this in here, it's going to go back to 5 because that's the smallest size is 5. Right, I'm going to do my best also to provide some rich menus. Here we have an integer menu, and on the right side it has the corresponding integer value for that option. So if I want to connect something to the method port and I want to have the nRandom qstrat option being picked, I know immediately that I need to use a value of 5 instead of going like 0, 1, 2, 3, 4, 5, right? I don't need to do that. I just immediately look on the right and I know that's the value that I need to input in there. The other thing is for geometry. I remember Softimage had a really nice autocomplete search box for attributes that existed on the geometry. And so that was very, very handy and speed up things a lot, avoid any typos. And I kind of miss that. Apparently we have some auto-completion for the file sub, so for files in disk, but not so much for menus yet, maybe in the future. But so what I'm doing in here is that I'm listing all the attributes present in the geometry. And so this avoids typos, but also it automatically picks the data type and the class of that attribute. And so this, hopefully again speeds things up and avoids, less clicking and less going through menus to just set something that it's already known. For geometry carry, also I'm going to use the string format to target a geometry. So instead of 0, 1, 2, 3, it's going to be OP input 1, OP input 0, OP input 2, etc. And so that's also going to be the default. It's going to be the first input instead of a file path in disk, like for the native nodes have. But there are other options, like there's a file path, there's an operator path, and the drop-down menu, there's some presets for this. This auto element option allows me to skip having to connect anything to the element. It's automatically going to pick an element based on the class of the operation and the context where Vex is running. So if I'm running this on vertices and I have the class point in here, it's going to use the ptnum and convert automatically from the vertex to the corresponding point ID. So I don't need to do any connection. The connecting something to the element1 port in here will override this behavior, even though this is a checkbox, but this connecting something here will override that. Most assets will have some fairly well-documented wiki style docs. There will be some images whenever there's some concept that it will be faster or easier to make the point across by just showing some image instead of just have some long-winded description. And at the bottom, they will have an example HDA that can be accessed by just clicking on the load button. And whenever you click on that, for example, for the connected elements, you'll see this network. And usually I'll try, whenever it makes sense, to have a practical setup. And here the practical setup for the connected elements is I'm setting 3 different types of neighborhoods into an array, and that array is passed to the find shortest path. And you can see that how those 3 different types of neighborhoods create 3 different patterns with the find shortest path. But for the most part, the interesting thing about these example scenes is to get to know the base cases and also see some of specific features of the asset and switch between on and off or a list of a menu. One thing that I remember Nodeway having in his HDAs was a description parameter that allows to quickly commenting on a node. So here I have this description parameter that I can type something in here, and I can have multi-line by clicking on this Pilcrow icon. And so, for example, here, if I find this node is useful, or I want to quickly comment on it, instead of using the comment, I can just use that. Of course, the comment is still available. You can still have the comment in there, but this is just a quick way of doing that. But by default, that description on the network is actually going to be used to avoid that you have to constantly click on a node to check the parameters to see what it's doing. So here, by just looking at this node in the network, I immediately know that it's building an array with size 5 and it's using the random BRJ method. So hopefully this will also speed up some things by avoiding constant clicking around to assess what's going on. These are the planned releases for Dash. So 2 already happened. The first one was representative of the topics or the subjects that I wanted to touch with the package, included some VOPs and some SOPs. The second release has the build arrays nodes, and the upcoming one will have the geometry nodes. And then here more topics that I'll be touching upon in further releases. So if you liked some of the concepts in here and you want to check on the project, go to GitHub. And if you want to discuss the project, that can be done on an instant form in Discord. Or if you just want to shoot me a message or check for updates, you can definitely follow my account on Twitter. Hopefully some of these ideas are worthwhile, and I hope to hear some feedback from you trying this Dash package. Cheers.